Hi folks, welcome to the channel. My name's Colin, call sign MM0OPX, and in this video I want to show you how to add 80 meters to your 40 meter end-fed half-wave antenna. Now, this little drawing that you can see in front of you here, I can't take credit for this, and I do apologise because I don't remember the source. I had it saved on my phone and I've just printed it out because it basically describes exactly what I want to do. So your normal end-fed half-wave for 40 meters through 10 is round about this figure. This is your length of wire, or 66 feet-ish. Now that's going to remain the same, but on the end of that we're going to add a 110 microhenry coil, and what that's going to do is this is going to load up this antenna, and it's actually going to give you 80 meters. Now, full disclosure, I've not actually put this antenna up with the coil yet, but it's a proven design and it will work. It's going to be a compromise because it's going to be effectively a quarter wave physical length of wire on 80, but it's going to get you there. Bandwidth is also going to suffer a little bit as well. From what I've heard, you get around about 100 kilohertz of 80 meters, so you're going to have to choose where you want that. For me, I'd probably just take that down the bottom end and get the digital end and CW, something like that. So as I said, this wire remains the same. So this coil also acts as a little choke. So this is your 40 meters up, and this little bit is 80 meters. So this approximately 2.5 meters, and this will basically enable you to fine tune by trimming to see where you want to be on the band. This is a very simple project. Really not expensive at all. I am actually thinking that if you have the items to hand, then literally this will take you maybe in parts maybe £1, $1, something like that. Really not expensive. So there is a few tools obviously you need, but I think most people will be able to get by with what they have, with their most basic household DIY tools. Right, so how do you work out what inductance your coil is going to be? Well, there's a very handy online calculator, and I believe the website is 66 Pacific. I'll put a link to that down in the description. And what you do is you just give it a number of parameters, a diameter of coil over a length, the spacing, and it gives you an inductance. And in my experience, it's very accurate. So if you make your coil exactly the same as the calculator, as far as I'm concerned, it's going to be good enough. I've actually made one of these already, and the calculation I got for 75 turns was absolutely right. It was within half a microhenry. So I would say do that. We don't all have a LCR meter, which I'll show you later, and that's going to basically use to confirm that what we have here is right. Again, if it's a few microhenries off, it doesn't really matter. You could just either lengthen or shorten the bit wire on the end. Right, let's show you what we need to get started. So, as I say, we used the calculator, 66 Pacific calculator, and I actually had some of this 36mm outer diameter PVC pipe that I bought I was actually for DIY something. It was a bit of plumbing, and I had some of it left over, and I knew it would come in handy. So it's approximately, and I've cut it 90mm long. It's not the best cut, but it doesn't need to be. It's going to be up in the air. What else do we need? Of course, we need the wire. This is basically magnet wire, enamel copper wire, and this is 0.63mm in diameter. And this is actually what I make my end-fed half-wave of as well. This is really just for QRP, I should have mentioned. If you want to make a 100-watt version of this, I think you'd probably need bigger diameter wire. We need a couple of cap screws. Allen head cap screws. These are M4x16, so 2 of those. We need a couple of ring terminals. These are 4mm ring terminals, and basically I'm going to remove the red plastic bits off the end. We need a couple of wing nuts or butterfly nuts. We need 2 M4 bolts. We need 2 M4 spring washers, and we need 6 plain washers. Now, I should add, these are all in stainless steel. I like to keep just a few. Again, these are not expensive. You could buy like 100 bolts, 100 nuts for like a penny each, or not even a penny each. They're quite cheap if you buy them like that. So where are we going to get started? Well, in my little garage notes book here, I've taken some notes, and this is a drawing that basically I made that will help you. So if you maybe want to freeze this, it might help. It's not the greatest drawing, but it should be enough for you to get by. So this is obviously elevation view of our coil, and this is basically to get your positions where you want to drill. So here's our 90mm length of tube, and you can see that I've just drawn a straight line. And how I did that was I just got this little bit of tube here, and I just put them against there, and I just drew along with a pencil, and that gave me a nice straight line. So first thing I need to do is I'm going to come along 12.5mm from the edge, and it doesn't actually need to be perfectly spot on, it just needs to be close enough. So I'm just going to go 12.5 like that, and I'm just going to take my 4mm drill I have and my cordless drill here, and I'm just going to drill a hole there. There we go, just like that, easy peasy. This is a great tool, just off Amazon. Got a rotary deburr tool. I first seen these when I was an apprentice engineer many years ago, and I lost it, but managed to pick up another one on Amazon, very cheap. I'm not saying they're the best blades, but you know, I'm deburring some plastic here, so they're never going to wear out. So that just takes the burr off of that. So that's where we want to start. So we can actually put that aside for a minute. We really want to start our wire. Now I just keep masking tape on this wire to stop it springing off. So what I'll do. Now I should add, you need around about 7 meters of wire to do this, certainly with what I've done here. So what this is going to be is this is going to be 75 turns of this wire around this 36mm former. Now you don't have to do this, but it makes it easier. So all I'm going to do is I'm actually just going to scrape the enamel off this wire here. So as you can see, there we go, stripped wire, just like so. I'm going to take my little ring connector, and I'm just going to remove the little plastic sheath. Now I need to get my ratchet crimps, and all I'm going to do is I'm just going to crimp this on. Like so. So there's our ring connector on there. Now, I don't want to just leave it like that. I'm going to just show you a little quick soldering trick, because we want to solder that on. And let me just see if I can find my solder. So I'm actually just going to solder this with the flame. It's much easier. Getting kind of low on gas this. Just want to heat up the connector till it flows in it. There we go. Done. Now we need to let that cool a little bit. So that's fitted on there. Now we need to actually fit this to here, like so. Which way am I going to do it? No, do it this way. I'm going to put a little bend in it just so it helps. There we go, like so. So see, just put a little bit of a curve on it there. So what we'll do is we'll get our M4 cap screw. We'll just put that through there. Like so. Oh. I think we'll actually do this first. We'll actually put our, should have had our plane washer on first, so apologies there. So put the cap screw through the bottom, put the plane washer on, put the connector on with the wire, put your spring washer on, and then put your nut on. We don't need to tighten that right up just now. It's probably better that you don't. But that's where we're going to start from. And I'm just going to see how I've just bent that there, because we're going to create this coil. So just tighten that by hand. There we go, like so. Now what we need to do is we need to actually turn 75 turns of this wire, and you want to keep them as close together, as possible. Now, I can't quite see it, but what I did before is, this is just a little bit fiberglass rod. I actually just put the 3 through the wire middle, used it as a spindle. I actually basically sat it on my chair and basically sat on it, so there was tension on it as I was pulling the wire off. So you won't be able to see that, but it's just an easy thing to do. So hopefully you'll see me winding in a minute. So it's basically just on the underside of my knees. There we go. Sorry. Right, now I'm trying to maybe get a turn on first, because you want to keep this tight, like so. I'm not happy with the tension that I've got on that, so I'm just going to... You want to pull it tight, you see. There we go. That's how you want it. Keep it nice and straight. Keep it up against the wire. But really, I need to start counting these turns, because I've not done that yet. So let's do that. So this is 1 turn, 2 turn, 3 turns. Four, 75. So that's 75 turns there. Exactly where that comes round there is 75 turns. So what I want to do is actually want to basically cut these. What I'll do is I'll cut that. What I'll do is I'm going to have confidence here. There we go. Just going to tape this off. I'll show you why. I don't want it to actually unravel. So there's our coil. So what I want to do now is I just want to remove a little bit of the enamel from the end. I'll just do that. So there we go. So there's our coil. And we're going to get this little gadget out, this little LCR meter here. Very simple to use. It's pretty much automatic. So it's already set to inductor, so it's looking for a reading. So what I'm going to do is I'm actually just going to get these probes. Let me actually just see if I can hook this on. One on is going to get a connection. Let's hope. Let's see. No, don't think it's getting a reading. No. There we go. How about that? 110. Oh. Yeah, it's just because I'm going to take a little bit more enamel off here. I think we're pretty much there. As I say, it doesn't need to be absolutely spot on. It just needs to be close enough, within a couple of microhenries. So there we go. You can see what's measuring at the minute, 107.4 microhenries. So to me, it's pretty much there. You know, we're not going to worry about, you know, not even 3 microhenries. It's going to be, you know, more than ample. So I'm quite happy to now actually fix the other end. And we'll check it again once it's finished though. So before we do that though, I'm actually just going to lock this end here. So I'm just going to put an Allen key in here. get my little quarter ratchet. I'm just going to lock this off. Doesn't need to be that tight. It's PVC pipe. If you over tighten it, it'll just dig in and bite on the underside. It's not as quite as easy doing this on camera. I'm trying to show you. There we go. So that's that side done. So I think I can just about see my line there. We want to just basically have this other bolt basically just parallel with this one. Again, if it's a little bit off, it doesn't really matter. So I'm just going to draw a line there. So I think it's about there. I think I need to draw along that line somewhere. And take our other little ring connector, do away with the red bit, the covering. Basically, I just want to put this in place. I want to see where it needs to be, the hole for it. So it needs to be about there. Actually, I better put my washer on there because that's what's important to get the hole position, because it's slightly bigger diameter. There you go. So this little mark here. So all I'm going to do is you could actually put a double. You could actually put a double one of these. You could basically have it on the connector, run it along around another bolt, and you know. But this is more than ample. Give it a little deburr again. What we'll do is we'll get our ring connector. And can I find my other bolt here in amongst the mess? Actually, just going to put it through from the top for a minute and put a little bend in it. So this is, I actually want to see where I want to actually cut the wire. So what I'm going to do, should have some snips some here. Bigger pair here. So here's our snips. So I'm just going to cut it. There. Okay. I'm going to take the wire, take this tape off, and then tape it again. But just do that. There we go. So we now need to remove the enamel off the end here, and I'm just going to do that. So that's all our enamel off there. And I'm just going to get our ring connector. I'm going to crimp it again. Like so. Should have put it in the ratchet first. And what we're going to do, we're going to solder it again. Just give it a little bit of a heat. Just check that's fully penetrated down and in. Yeah, that looks pretty good to me. We're just going to let that cool. While we're doing that, we could just bring our bolt through from the bottom. It's going to need a little bend in it actually. That's okay. Just want to keep our coil tight as we can. So again, here's our washer, is there. Oops, come through from the bottom. I'm trying to show you this on camera. There we go. spring washer on our bolt. Just going to tighten that up. I could have had a touch more tension on that, but when it's secure, you're never actually going to notice that. There we go. Now, that's our coil wound complete. Now, all we want to do is actually check the inductance again and see where it is. And hopefully it's not changed. Hopefully you can see that on the screen. Just going to touch this on the terminals. It's came down a very slight amount. So yeah, I'm not complaining at that. If you know, I did this exactly as per the calculator, and you know that's how it's come out. So it's come out pretty close. The last one was actually slightly better than that. This is actually it here. I think this one actually worked out. This is just some heat shrink that's round about it. You don't really need it though. You can see that's 110.7. Well, there's 75 turns on that as well. But if you have got an LCR meter, what you can do is you can actually wind an extra couple of turns, check it, come back, come back, come back. That's probably the best way to do it. But a lot of you won't actually have LCR meters or a way to check the inductance accurately. So that's all that you need to do. You can put some heat shrink round about it if you want. Personally, I don't think you need it. You could maybe put some, you know, maybe a little bit liquid tape around the connectors, but you know, it's not required. You know, if it's going to be up for a long time, you maybe want to use a former, you know, that's maybe UV resistant. Just finish it off with the butterfly nuts. So there we have it. Really simple to make. You could do it with really basic tools, very inexpensive, and it's going to get you 80 meters on your 66-foot end-fed half wave. So there's 101 different ways to do this. It doesn't have to be on this diameter. It could be a bigger diameter, smaller diameter. It's really up to you. As long as you go by what the calculator says, work with what you have, and it will work. So I'll need to do a video actually with this on an antenna itself. I've not done that yet. I've not even had it up. I'm embarrassed to say, but you know, it's certainly on the list to try 80 meters on my end-fed half wave. Okay, folks, I hope that's been of some interest. You know, if you're wanting to make one of these, you know, hopefully that's, you know, giving you the idea of what to do, the technique, items that's needed, and so on. But there's really not a lot to it. So 73 folks, all the best, and we'll see you on the next one.